The last assumption, R6, is the random errors follow normal distribution. Now there are two or three different ways or two different things that you can look at for verifying this assumption. So we can plot a histogram of residuals and see whether there is an approximate bell shape. And there is this Excel normal probability plot. If the points on the normal probability plot lie along a straight line, then that indicates that the residuals follow normal distribution. Okay, and we can also examine the plots with against both time and fitted values. And one more thing is, if you take the standardized residuals, okay, so if in a normal distribution, if you look at the bell-shaped curve, about if you take plus or minus 2 variance, okay, 95% of the, about 1.96 is the z value, for which 95% of the values should fall within plus or minus 1.96. So if you look at, and let's approximate to 2. So if you look at the residuals, and then if you see 95% of them are within plus or minus 2, in other words, about 5%, no more than 5% fall outside the plus or minus 2. That is another indication that maybe normal distribution is all right. So in combination with a bell-shaped distribution and only about 5% of the standardized residuals, not regular residuals, standardized residuals fall outside plus or minus 2, that also will indicate the normal distribution assumption is probably okay. So let's go to the Excel file and then see what plots we already have and what plots we have to generate. Okay. We already have the normal probability plot when we ran. So this is the Excel normal probability plot. Remember, we generated that when we ran the data analysis. So let's move that. So if you look at this, it is if you draw a straight line, I don't know whether the points fall on a straight line or not. We can try to insert a straight line by selecting the plot, and then you do, okay, so you have plus and then a trend line, so that will insert a trend line. So it's kind of not very promising, but let's look at the percentage of standardized residuals that falls outside plus or minus 2. So the total number of residuals is the count of residuals, and remember, this is standardized residuals we're talking about. Okay, now how many fall outside the upper limit? So we can do a count if okay, the standardized residuals, okay, comma, so we have to do within quotation marks greater than 2. Okay, now do the same thing, but this time, okay, the standardized residuals, right, comma, now within quotation mark less than minus 2. So these are the number of residuals outside the plus or minus 2 limits. So those are 8 of them. So that will be 8 out of 155. So that's in percentage terms, that's about 5%, little over 5%, but that's all right. So this is promising. So there is one test that it passes. Okay, one test it doesn't pass that well. So now let's look at the histogram of the standardized residuals and then see whether that has an approximately bell shape. If that is so, then that would be all right. Next, let's develop a histogram and a bar chart, histogram, frequency distribution histogram for standardized residuals. So we're going to use pivot table for this. So let's prepare the pivot table here, and then we will move it back down to the proper place. So standard residuals, highlight the entire standard residuals column, okay, and insert pivot table. Now let's put the pivot table somewhere where it won't mess up any of the existing data. So like maybe here. Click OK. Now standardized residuals, put it in the rows. Okay. Now again we have to put standardized residuals in the values area too, but we need to change that from sum to count. How many standardized residuals fall in each group? So change that from value to count. All right. So now we have count. Okay. But our pivot table has one row for each standardized residual. So we need to group that. So select any value here, right click and go to group. And let's group this from say minus 3.5 all the way through positive 3.5 in increments of 0.5. Okay. So now we have our pivot table. Okay. All right. Now let's move this pivot table to where we want it, right there. So now we have the frequency distribution. Now what we want is a histogram. So select the pivot table and go to analyze, go to pivot chart, and you have the bar chart already selected. So let's just accept that. Okay. Now this is a histogram, so we need to remove the gaps. So select now, right click, say format data series, and you see gap width, take that down to 0. Okay, and then we don't need this legend, so let's get rid of that. So now we have the histogram. Now histogram is slightly skewed to the right, but it has a somewhat normal distribution, kind of symmetric distribution, a bell-shaped distribution, even though it is not a perfect bell, which is not a problem, which is okay. If it's not a perfect bell, it's still okay. It is somewhat close to a bell-shaped distribution. So based on these three analyses, the normal probability plot, well, it is kind of inconclusive. It's not a good fit. But here only about 5% of the standardized residuals fall outside plus or minus 2 limit, which is good, which is consistent with normal distribution assumption. And the histogram is, even though it is not a perfect bell shape, it is somewhat like a bell shape. So based on all these three different plots, we can conclude that normal distribution assumption is not violated. So here is the discussion. Normal probability plot is from Excel is inconclusive. There is only 5.2% standardized residuals falling outside plus or minus 2. And the histogram of the standardized residuals shows somewhat of a symmetric pattern, quite close to normal distribution. Therefore, we can assume normal distribution for the residual errors.